Hello students, welcome to my next online class, and this is the continuation video of current electricity, and the topic which we are going to start our today's class is the meter bridge. You see, it is a practical application of Wheatstone bridge, or you can say it is based on Wheatstone bridge. So we have learned in the previous class what was Wheatstone bridge. You see, four resistances were connected in a form of bridge, and when a potential at point B and potential at point D, when it becomes same, so we see that there is no current passing through this galvanometer. Therefore the galvanometer shows null or zero deflection, right? So we can say that this P and Q are in series and R and S are also in series. So likewise, out of four resistances, if three resistances are known, then fourth, that is unknown resistance, can easily found out. Okay, so this is the practical application of this Wheatstone bridge. Therefore meter bridge, it says as meter bridge because we use here wire of 100 centimeter, that is 1 meter, right? So 1 meter wire is fixed between A to C. Now you see, R is the resistance box which we will be using. This 100 meter wire is being divided into two parts. Let us consider first A to D is L and D to C, that is 100 minus L, right? We know in a balanced Wheatstone bridge principle, P by Q must be equals to R by S, right? So here, in order to find this unknown resistance, this S is here unknown resistance which we need to find. Okay, now you see, we know P by Q equals to R by S, right? So again, resistances. Now if I say what are the factors upon which the resistance of a wire depends, so resistance of wire depends upon the resistivity, that is nature of the wire. It depends upon the length of the conductor, also it depends upon the area of cross section. Now if I consider this resistance here, this R has to be as P. Okay, that means I am comparing this P with this resistance R, right? So P will be rho L by A. So this from A to D I have considered here P, right? So P equals to AD here, the resistance of AD here. So P equals to rho L by A. Now next you consider DC. Likewise, resistance is being changed by Q. So Q equals to rho L by A. Now in place of L, what is the length here? That is 100 minus L. That is, in place of L I will be substituting 100 minus L. Now area of cross section remains same because it is same 1 meter wire which is divided into two parts, right? So A remains same. Now you see, this was I have considered this one equation number 1, equation number 2. So dividing equation 1 by 2, so when we divide P by Q, right hand side also get divided. Now everything will get cancelled and we will find L by 100 minus L. So therefore P by Q equals to L by 100 minus L, and we know P by Q equals to R by S. Therefore R by S equals to P by Q, that is L by 100 minus L. Now out of here, you see, if we know this is a jockey, when we place in the wire, when we slide on the wire, at a certain point we will be getting the null point. So when we will get the null point, that means we can say this is a potential divider, and at this we are getting zero deflection. That means this point here, it is showing null point, right? So we will consider P by Q equals to R by S. Same here, when these 2 points were at same potential, no current was passing through this. So we said that these two resistances and these two resistances were in series and their combination are in parallel, right? So we say that here R by S equals to P by Q. So from here we can get, we know the L, if we know if it is at 45, then definitely other will be at 55 because 100 minus 45 is 55. So L will be knowing here, R resistance, that is known, that one we will be changing while calculating S. So after cross multiplication we can get the value of S easily, right? So what is meter bridge actually here? Meter bridge is the practical application of Wheatstone bridge, where we use the concept of balanced condition of Wheatstone bridge here. P by Q equals to R by S. So R is the resistance box, S is the unknown resistance which we have to find, and we will just slide the jockey on the wire, that is meter. meter wire. Now at a certain point we will be getting the balancing point. Wherever we get the balancing point, that is our length L, and we will subtract from 100, then we will get 100 minus L, that is, and after that we will cross multiply and we will get the value of unknown resistance S. So this one also you will be writing in your exercise book. So next we have potentiometer. Potentiometer is a device which is used to measure the potential difference accurately. Now you might be thinking that what is the use of voltmeter then? Voltmeter also calculates the potential drop here, but you see potentiometer does it very accurately. So the sensitiveness of this potentiometer is more than that of other devices, right? So here we'll learn how does it work. You see, it has two circuits. One is called the primary circuit and one is called the secondary circuit. Here in the primary circuit we have a driver cell, that is driver EMF. I have considered here B1, right? Now in the secondary cell we have the secondary battery, that is, let us consider here E. Now we are comparing our EMF with a standard EMF. Like you see, in order to find the potential difference between point A and B, we need to calculate here this EMF, that is E and B1. So we can compare the EMF of two cells by using the potentiometer also. Like here we will be connecting here two cells, that is two batteries. Like let us consider that everyday battery we can say. So if one is used and one is just, you can consider as new one, that two if I place here, that can be easily comparable, means we can compare that which battery we have already used it and which one is new, right? So this sort of practicals also we need to do in our lab, right? So this type of practicals also we have. Now you see, how does this work? Like you see, first of all, a jockey is, the negative of a jockey is connected with the negative terminal of the battery, and all the positive terminal is connected to point A. Like you see, the driving circuit, driver battery is also connected to point A. Now when you connect the jockey is the potential divider, that is an instrument which is used to divide the potential. Now when we slide from A to B, at a certain point we will be getting the balancing point. Now that means this jockey is connected with the galvanometer, and the galvanometer, this arrow is the galvanometer. This galvanometer will show the zero deflection. So wherever we get the zero deflection, we can say that at that point the potential is exactly divided. Now it has been seen while sliding this jockey within this 100 centimeter wire, that on increasing the length, when we just increase the length from A to B, then we have seen the drop is maximum. That means the potential drop is directly proportional to length. That was we say here, B is directly proportional to length. That potential drop we have considered here as E. E is directly proportional to length, or E equals to KL, right? Where K is the potential gradient. Here we say K is the potential gradient, or potential gradient equals to E by L. Now with this principle, so if I say what is the principle of the potentiometer wire? So potentiometer is a device which is used to measure the potential difference accurately. The sensitiveness of the potentiometer wire, a potentiometer device, is more than that of voltmeter, right? Here the potential difference is directly proportional to length, where E equals to KL, where K is the potential gradient, right? So same here, this K, which is written in terms of V here, so K can be written as V by L. Now what is L here? L is the balancing length. Now you see, I have drawn here three arrows, so it doesn't mean that there are three circuits here. So first I have kept at point P and I have calculated the length L1. Now again I have calculated, placed at point P2, that these are the positions, right? So these are the not different circuit, these are the positions where we have placed the jockey, right? So we have slide it from A to B in order to get the balance point. So as we get the balance point, so we say that that length is our balancing length, and that L is equals to V. So likewise we have to calculate E here. Sometimes it is being asked to calculate the potential gradient. So in the screen you can see two EMF E1 and E2, which is in secondary circuit, and it is a battery B. So this is the battery B, and this is the driving circuit, and this is the secondary circuit, right? So in the secondary circuit we have E1 and E2. This EMF we can compare by using this potentiometer. So you can see the positive terminal of E1 and E2 both are connected to terminal A, and the negative terminal is connected to K1 and K2. These are the keys which are further connected with galvanometer and this jockey J. Now in order to compare these two EMF E1 and E2, first what we do, we keep this K2 open and we close the key K1 and K2 be closed here. Okay, so when we close here this K1, the current from this battery will pass through this wire also, and it will pass through this circuit, that is you see through this K1, because this battery, the EMF of battery B is greater than battery, that is EMF E1, right? So the direction of current will be getting here, and will be getting here balancing length, let us consider to be as L1. Okay, so we know that if we increase the length, the potential difference or the potential drop will increase. Therefore you can see the equation here, E1 equals to KL1, right? So E1 is the battery of E1 here, and K is the potential drop, and L1 is the balancing length when we closed K1 and when we opened K2, right? In the second case what we do, we close both the keys, we include this K2 also. When we include this K2, we will be getting the balancing length for E2, right? So we can say that E2 equals to KL2. Now let us consider this equation number 1 and equation number 2. When we divide equation 1 and 2, we will be getting E1 by E2 equals to L1 by L2. While sliding the jockey in the meter wire, we see that when we place our jockey in the near to A, then we will get a left hand side deflection. When we place on at point B, we will find the right hand side deflection. So likewise we will keep on checking the left and right deflection, and at a certain point we get the balancing point. So wherever we get the balancing point, that is our balancing length, and therefore we compare the EMFs of both the batteries. So this is the circuit diagram for calculating internal resistance of a battery using the potentiometer wire, and this is the expression, that is small r equals to capital R L1 by L2 minus 1. So likewise we can also find that when K1 is closed, then we will be getting here KL1, we will get a balancing length. Let us consider this as to be as L1, right? Now when we open this one and when we close this one, we will be finding K2, that is KL2, right? So when we will find E1 and E2, we will just divide both equation 1 and 2. When we will divide equation 1 and 2, we will be getting E1 by E2 equals to L1 by L2. Now both the balancing lengths are known, and out of two EMF, one EMF will be known, and the next EMF can be easily found out. So in the screen you can see one question. A potentiometer wire AB is 4 meter long. Where should the free end of the galvanometer be connected? This is the free end of the galvanometer be connected to AB, so that the galvanometer shows no deflection. Or zero deflection, meaning is same, right? So where will be the point P should be placed? Now you see in this question 8 ohm and 12 ohm already it is given, and we need to find at what point P we will be getting the zero deflection here. So we know from Wheatstone bridge condition P by Q equals to R by S. Now here what is our R? R is our 8 ohm, our S is 12 ohm, and let us consider this P as to be as X. So at a distance of X from point A, we are getting the zero deflection here. Now if from A to P, if it is X, then what will be P be here? total was 4 meter, so 4 minus x, that is 4 minus x, right? So I have noted down here all. Now at Wheatstone bridge condition, we know P by Q equals to R by S. Same here. Now in place of P, I am substituting all the values, that is x, in place of Q 4 minus x, in place of R 8 ohm, and in place of S 12 ohm. Now when we cross multiply, we get the value of x here, right? That is 1.6 meter. That means at 1.6 meter here, we will find the balancing length, that is zero deflection. So this question will be your homework, right? That is question number 9. You see, last class I have taught you Kirchhoff's law. So based upon that, you have to solve this one. So you need to calculate here I1, I2 and I3 current. That is I1 answer is given 1 ampere, I2 2 ampere and I3 3 ampere. Also try to solve the short answer type questions. You see in the screen, state Ohm's law, on what factors that the resistance of conductor depend. So I hope you have got your textbook. You search answer from that and you note down in your exercise book. So these are the few questions more. And you need to find the answer of this question. Find the value of x here. Okay, this is the circuit. Answer of this question is 6 ohm, right? And you will find the current passing through this circuit. You see the circuit here. So what will be the current here? You will be finding. Most probably you will be getting 0.1 or 1 by 10 ampere. Okay. So all the resistances are here 30 ohm. So answer is 0.1. So for this class only this much. And you write the notes from your book of potentiometer and this meter bridge and practice as much as numerically you can. Thank you.